Hello and welcome back to Go Figure. Today we are on Lesson 39 of Saxon Algebra Half, Equivalent Equations and the Addition-Subtraction Rule for Equations. So let's start with a couple of warm-up questions and we'll just go through them together really quick. Number one, what is a solution to an equation? You remember a solution is just the answer to an equation, meaning the value of the variable in an equation. Number two, solve 4x equals 24. So in this case, we are saying 4 times a number equals 24. So obviously x here is going to equal 6. And number three, solve y minus 9 equals 21. In this case, y is going to equal 30 because 30 minus 9 is 21. Our learning objectives today are to identify equivalent equations, go over the addition-subtraction rule for equations, and then solve equations. So equivalent equations have the same solution, the same answer. So here's a set of equations that all look different, but if you look closely at them, you will notice that each one, the solution is 7. So number one, the first one, x equals 7. That just gives us the answer right there. But then if we substitute 7 in for x for all the rest of these, we'll see that these are true equations. 7 plus 4 equals 11. 7 minus 3 equals 4. 3 times 7 equals 21. 14 divided by 7 equals 2. So these equations are known as equivalent equations. So when we are solving more difficult equations, we are going to need some rules or properties to follow as we solve these more difficult problems. So the first one is the addition-subtraction rule. And we can think of an equation like a scale that needs to balance. And so what you do to one side of the equation, you're going to need to do to the other side in order to keep that balance. So if you could think of, imagine that was straight, but there's a scale. And if you had, let's say we have 3x over here, and we're going to equal it to 12. So that means that 3x is the same as 12. It's balanced. And so if we wanted to change this equation at all, make it look different, we would need to do the same thing. So let's say we wanted to add 1. If you add 1 to one side of the scale, that's going to tip it, but I want to keep my equation balanced, so I'm going to have to add 1 to this side of my scale as well, just to keep that equation equal. So the first part of our rule is that the same number can be added to both sides of an equation without changing the solution to the equation. So this is known as the addition property of equality because your equation stays equal when you add the same number to both sides. And likewise, the same number can be subtracted from both sides of an equation without changing the solution to the equation. And this is known as the subtraction property of equality. And we would use this rule or these properties to isolate the variable in an equation and therefore be able to solve for that. So that's the key. When we're trying to solve an equation, we're trying to isolate that variable, get it all by itself on one side of the equal sign so we can find out what is its value. So our first example, x minus 5 equals 12. Now, obviously, you could probably do this in your head, but starting really now in this course and going forward as we get farther into pre-algebra and algebra, we're really going to have to work on the formatting of how we solve these problems and like the structure of how to solve these. So it's really important to learn just how to write these out. So in this case, so we're subtracting 5 from x, but we want to get x all by itself to figure out what does it equal. So the way that we would do this is we would rewrite what we started with, x minus 5, but then to undo this minus 5, we're going to add 5, okay? And then we'll write our equal sign, and we know that since we just added 5 to the left side of our equation, we need to also add 5 to the right side of our equation. So I'm also going to add 5 here. And now when we simplify this, we'll go down to a new line and simplify. So we have x minus 5 plus 5 leaves us with just x, right? And then 12 plus 5 equals 17. So I'm sure you could have figured this out in your head without going through these steps. But trust me, it's going to be very helpful to know how to write all this out as we get into more complicated problems later in the course. So get used to writing it out now. So here is our solution, x equals 17. And then oftentimes in your book, it's going to have you check your answer. So the way that we check our answer is just take our solution, 17, and we plug it back into our original equation. So we're going to put 17. And usually what happens is we'll put parentheses around where our variable was, so we know which number is being tested, I guess you could say. So 17 minus 5 equals 12. Simplify, yes, 12 does indeed equal 12. So that checks out. Next example, y plus 2/3 equals 6/7. So here we are adding 2/3. Now if we want to isolate our variable y, get it all by itself on this side of the equation, we're going to need to subtract 2/3 now. So we're going to rewrite this as y plus 2/3 and then minus 2/3. Our equal sign, and since we subtracted 2/3 from the left side of our equation, we also need to subtract 2/3 from the right side of our equation to keep it balanced. Okay, so then we're going to simplify for our next step. So 2/3 minus 2/3 is 0, so that means we're just left with y, we're left with our variable, which is exactly what we want. And then in order to subtract our fractions, we need to use what we've learned before and get common denominators for these fractions in order to subtract them. So 7 and 3, that common denominator would be 21. So that means we would have, we're multiplying by 3, so we'd have 18 over 21. And then here we're multiplying by 7, so we're going to have 14 over 21. And we want to simplify again. We have 18 21s minus 14 21s equals 4 over 21. Okay, so there's our solution, y equals 4 over 21. And then to check our answer, we're going to substitute this answer, this solution, into our original equations. Okay, so let's test our answer, 4 over 21 for y. Plus 2/3 equals 6 over 7. And again, we need common denominators here, so we're going to, which would be 21 again. So 4 over 21 plus, and we're multiplying these by 7, so 14 over 21. Then we still need to simplify, so this is 18 over 21. Equals 6 over 7, and then we can simplify this fraction, 18 over 21. We can factor out a 3 from the numerator and the denominator, so that leaves us with 6/7 equals 6/7. So that checks out. All right, third example, z minus 4/9 equals 1/10. So here we're subtracting 4/9. So to isolate our variable, we need to add 4/9 to both sides. So I'm going to start rewriting our problem, but then add 4/9. What we do to one side, we need to do to the other. So we have 1/10, and we're going to add 4/9. Okay, so now we simplify. On the left side of our equation, we're left with our variable z. And on the right side, we need to have common denominator. So between 10 and 9, our common denominator is 90. So that makes our first equation 9/90. And then our second equation, we're multiplying by 10/10, so 40/90. And then we need to simplify, add them together, we get 49/90. Then we could go ahead and check our answer, use the solution, put it back into our original problem. So we're going to do 49/90 minus 4/9 equals 1/10. Okay, we need common denominators in order to subtract here. So 49/90 minus 40/90 equals 1/10. Then we'll simplify this. 49 minus 40 is 9. 9/90 equals 1/10. And we can simplify this fraction. That is indeed 1/10 equals 1/10. So that checks out. There is our solution. Z equals 49/90. And if you ever checked your answer and you got different numbers in your final equation, your solution, then that means you need to go back and try again, or maybe you need to recheck just to make sure. But these should always be equal when you do your check. So here's your practice problems from the book. Go ahead and pause the video and solve them. Do the check your answer, and remember to simplify. If you can simplify fractions, go ahead and do that. So go ahead and pause the video and press start when you are ready to check your answers. Okay, first one, A. A plus 4 equals 6. All right, so this is an easy one, but just get in the habit of going through the process of writing this all out. So we're adding 4. That means we need to subtract 4 to isolate our variable. If we subtract 4 from one side, we need to subtract 4 from the other. And then we're left with our variable A equals 2. And to check our answer, we would plug 2 back into our original equation. 2 plus 4 equals 6. That checks out. Next one, x minus 2 equals 4. Again, another easy one, but just getting in the practice. X minus 2, we need to add 2 now to isolate our variable. Add 2 to both sides to keep it balanced. That leaves us with x equals 6. And then check our solution, plug back 6 into our original equation. 6 minus 2 equals 4. That checks out. Next one, x plus 1/2 equals 3/4. So we want to subtract 1/2 from both sides. So then on our right side, we have 3/4 minus 1/2. Then our next step is to simplify, so we're left with x on the left side of our equation, and then we need common denominators to be able to subtract our fractions. So common denominator is 4 here. So 3/4 minus 2/4. Simplify some more, we get x equals 1/4. And if we check and put 1/4 in for x, let's just do that over here. And again, when you are checking your answers, go ahead and put parentheses where your variable was. Rewrite all the rest of it. Okay, we need common denominators, so that is 4, 1/4 plus 2/4. Equals 3/4, and yes, when we simplify that, 3/4 equals 3/4. So that checks. And last one, x minus 1/3 equals 11/12. So we need to add 1/3 to both sides of our equation. I'm going to rewrite the original, add 1/3. What I do to one side, we need to do to the other. So 11/12 plus 1/3. Then we simplify. On the left side of our equation, we're left with x. And then we need common denominators to add these fractions. Our common denominator is going to be 12. So that would leave us with 4/12. And then we'll simplify again. We have x equals 11 plus 4 is 15. 15/12. Now we can simplify this because this is an improper fraction. So 12 goes into 15 once. There is 3/12 left over, and we can simplify that even more by factoring out a 3 from that fraction. So we would be left with 1 and 1/4 as our answer. Then we can go ahead and check our answer by plugging in 1 and 1/4 for x here. And I'm going to go ahead and actually put that into an improper fraction to start with. So 4, 5, that would be 5/4. Put parentheses around where my variable was. Minus 1/3 equals 11/12. 11/12. Okay, we need common denominators here. Between 4 and 3, that's 12. So we'd be multiplying by 3 here. 15/12 minus 4/12 equals 11/12. And yes, 15 minus 4 does equal 11. 11/12 equals 11/12. Our answer checks. Good. Okay, so to summarize, equations must balance just like a scale. So you want to perform the same operation on each side of the equation to keep it balanced. And we just use the addition and subtraction properties of equality to isolate the variable. Your goal is to get that variable all by itself on one side of your equal sign. So next you can do problem set 39 and then read ahead to lesson 40 in your textbook. That's all for today. Have a great day and see you next time.